Okay, it is time to talk about the second section of Chapter 8. Yesterday, or in the last video, we talked about multiplying and dividing rational expressions. Today, we're talking about adding and subtracting them. So of course, just like with fractions, multiplying and dividing is a different process than adding and subtracting. So our main goals today are to be able to figure out the LCM, or the least common multiple of polynomials. And then of course, we're going to add and subtract rational expressions. So just a reminder of some of the vocabulary, LCD and LCM. Just like with rational numbers that we write as fractions, if I'm going to add or subtract rational expressions that don't have the same denominator, I have to find the least common denominator, right? I have to find a common denominator. And the common denominator is the least common multiple of the denominators. So remember, a multiple is either the same size or bigger. So if we look at this example with numbers, 18 is the least common multiple. If I start listing the multiples of 9, I get 9, 18, 27, etc. 9 times 1, 9 times 2, 9 times 3. The multiples of 6 are 6, 12, 18, and so on. 18 is the smallest common multiple. So it's a multiple of both, and it's the smallest one. So if I'm going to find the LCM, or the least common multiple of numbers or polynomials, I have to think about factors. Of course, factor first. The least common multiple, the thing that's going to be my denominator, contains each factor the greatest number of times that it appears as a factor. So how does this work with numbers? With 6 and with 9, well, I break 6 down into its prime factors. So 6 is 2 times 3. Then I have to break 9 down. 9 is 3 times 3. So I have to use 2 in my common multiple, right? And then I have to use 2 3's, right? So that I make sure that 9 shows up down here too. So I end up with 2 times 3 times 3. That's what it means by saying that I use each factor the greatest number of times it appears. So in this least common multiple, 18 is divisible by 6, right? Because it has a 2 times 3. And 18 is also divisible by 9 because it's 3 times 3. It works the same way with polynomials. Here, if I'm going to add these two fractions, I need to find the least common multiple of this and this. So to do that, I need to factor first. When I factor x squared minus 3x plus 2, I get x minus 1, that's one factor, and x minus 2, that's another factor. If I factor 2x squared minus 2, I factor out the 2 first, and I get 2 times x squared minus 1. And then x squared minus 1 factors into x minus 1 times x plus 1. So this one has 3 factors, 2, x minus 1, and x plus 1. So I have to make sure that each of those factors is represented down below. So there's my 2, there's my x minus 1, x minus 2, and x plus 1. So everything in this polynomial, my factors, all appear down here, right? If I'm looking for x minus 1 times x minus 2, I've found it. If I'm looking for 2 times x minus 1 times x plus 1, it's there. So I have to make sure all of my factors are represented down here, the maximum number of times that they appear as a factor. So even though I see 2 x minus 1s, x minus 1 only appears once here and once here. All right, so let's practice finding the least common multiple. Here I have 3 different monomials, right? And notice that in this case, these are, again, monomials, not polynomials. Well, it's a kind of polynomial with only one term, but there's no addition or subtraction. So I need to break down and factor all of my monomials. So 15 is 3 times 5. We'll start by thinking about the numbers. 16 is 2 to the 4th, 2 times 2 times 2 times 2. And 20 is 2 times 2 times 5. So my least common multiple needs to include each factor the greatest number of times it appears. So I need a 3 there and a 5, because those don't appear in the other ones, right? And then 2 to the 4th. 2 squared is already included in 2 to the 4th. 2 to the 4th is the maximum number of times 2 appears in any one factor, or in any one monomial. So that's part of my least common multiple. And then I look at my variables. So I have a squared and I have a cubed, so I can write a cubed. And then I have b to the first, b to the fifth, so I use b to the fifth, because that's the greatest number of times it appears as a factor, and b divides into b to the fifth. And then I have c cubed, c squared, and c to the sixth. Again, where's the biggest? The one where c occurs the most times, c to the sixth. So my least common multiple is 240, a cubed, b to the fifth, c to the sixth. I have to make sure that every denominator that I have originally back here, or I'm sorry, each monomial, we're not talking about fractions yet, each one of these has to be a factor of my least common multiple, meaning if I take this divided by any one of those monomials, it should go in evenly. All right, let's do this with polynomials that include addition and subtraction. So these are not monomials. So I factor my first polynomial. I start by factoring out the GCF of x. And then I factor x squared minus x minus 2 into x plus 1 times x minus 2. My second polynomial factors into x minus 2 times x minus 2. So my least common multiple, I need to include x, x plus 1, and then x minus 2 squared, because x minus 2 appears once here, twice here. I need to include it the maximum number of times it appears in one expression. So x times x plus 1 times x minus 2 is the least common multiple. So here is one for you guys to try with monomials. All right, in this case, your answer should be C. 36 is the least common multiple of 6, 9, and 4. Then I choose x cubed, y cubed, and z squared because each of those are the maximum number of times that that variable appears in one monomial. Okay, try this one with polynomials. Okay, the answer here is A. I'll show you the factoring. All right, so again, my least common multiple needs to include each factor the maximum number of times it's used in one expression. So here I have x reflected here, x plus 3, but it occurs twice over here, so I put it twice in my least common multiple, and then x minus 1. So all of those appear in my least common multiple. So now we're going to talk about how we actually add or subtract. When I add or subtract rational expressions, I have to get a common denominator. So if I have a over b times c over d, remember I multiply each fraction by something that's equal to 1 by the missing factor. I do that in both fractions so that I end up with the common denominator. In this case, my common denominator is b times d. And then I add my numerators and the denominator stays the same because remember the denominator kind of means the size of the pieces that I'm cutting things into. Subtracting works the same way with a common denominator. So pay very close attention to the kind of denominators you have. In this case, we have monomial denominators. And so I need to find the least common denominator. That means I need to find the least common multiple of 6b and of 14a squared b squared. So I recognize that 6 is 2 times 3 and 14 is 2 times 7. So my least common denominator is going to be 2 times 3 times 7, and then I have to include a squared and b squared. 2 times 3 is 6, times 7 is 42. That's where they get this least common denominator. So now I have to ask myself, what do I need to multiply 6b by to get 42a squared b squared? Meaning, what factors am I missing? Well, I already have 2 times 3, which is 6, and I have a b, so I'm missing 7a squared b. So I do that on numerator and denominator. I multiply. My other denominator is 14a squared b squared. All I'm missing is the 3, so I multiply by 3 over 3. Because remember, we're not changing the value because I'm multiplying by something that's equal to 1. So I simplify. I do the multiplication, which you can see here, and then my denominators are now the same. So I can add them into one single fraction, which looks like this. And that would be my final answer. Okay, so I want you guys to check, try this one and see how you do. The answer here should be D. Your least common denominator should have been 12xy squared. So I'm going to multiply each fraction by something equal to 1 that will make my denominator 12xy squared. And here is the process for doing that. So notice in this case, I didn't even have to multiply the second fraction by anything because its denominator was already the least common multiple, or the least common denominator. My first fraction I needed to multiply by 6xy over 6xy. Okay, so let's see how this works when I have denominators that are not monomials. So again, I'm going to have to factor each denominator first to see what they have in common and what I need to include in my least common denominator. So 3x minus 15, I factor out a GCF of 3. 6x minus 30, I factor out a GCF of 6. That means that my least common denominator is going to be 6 times x minus 5. Why? Because 6 is 2 times 3, so 3 and 6. 6 would be the least common multiple of those two, and then x minus 5 needs to appear once. So what happens is that the only thing missing in my first fraction to make a common denominator is a 2. 2 times 3. So I multiply by 2 over 2, and I end up with a denominator of 6 times the quantity x minus 5. And then I just do my subtraction. 2 times x plus 10 minus 3x plus 15. Notice the quantity, so it's in parentheses, so I make sure to distribute that negative. And this is my common denominator. So now I have them written as one fraction. Then I just distribute. So basically I'm taking my 2, I'm getting 2x plus 20 minus 3x minus 15. And then I simplify by combining like terms. 2x minus 3x is negative x. 20 minus 15 is positive 5. Now, you have to be careful because if I can simplify after I've added, I should. So basically what they're showing you here is that they factored a negative 1 out of my numerator, and notice that gives me x minus 5. So just like in section 1, x minus 5 divides out to 1, and I'm left with negative 1/6 as my final answer. You have to simplify at the end if you can. All right, so here's one for you guys to try. Don't forget to factor first, find your least common multiple, and then multiply by what's missing. All right, your answer here is negative 1/4. I'll show you the work. All right, and there is the work. Again, I only needed to multiply one of my fractions by 2 over 2 to get my least common denominator, 4 times the quantity x minus 2. And then we followed basically the same process as in the last example. I get my common denominator, I subtract the numerators, distribute, simplify, and then see if I can factor and simplify again at the end. All right, let's talk some more about complex fractions. So this is combining the idea of complex fraction, or a fractions divided by a fractions, where I have to get a common denominator first. So my goal with a complex fraction is to have one fraction in the numerator and one fraction in the denominator. Here I have two fractions here and two terms, one fraction and one integer here. So what we're going to do is figure out first our least common denominator. So in this case, a times b is going to be my least common denominator. So I have to multiply my top fraction by b over b and my second fraction by a over a. So I end up with b over a times b plus a over a times b. In the denominator, my least common denominator is b. So remember, I can think of this as 1 over 1. So I need to multiply that by b over b. So I end up with 1 over b minus b over b. Now I'm going to add my fractions in the numerator and the denominator, right? So b plus a all over ab, and in the denominator 1 minus b all over b. So now I have a single fraction in the numerator and a single fraction in the denominator. And then I rewrite. Remember, this is like a division sign. It means b plus a, the quantity of b plus a over ab divided by 1 minus b, the quantity of 1 minus b over b. Then I can just go back to section 1 and say, okay, I need to leave the first fraction the same. When I'm dividing fractions, I change and I multiply by the reciprocal, right? So when I do that, I have a times b in the denominator and a b in the numerator, so those divide out to 1. And I'm left with b plus a over a times the quantity, 1 minus b. There's nothing else I can cancel. This a is a term, this a is a factor, so I cannot cancel those. So I can write it either one of these two ways. Okay, and I want you guys to try this one. The answer here is D. there's the process. Again, my common denominator in the numerator would be AB and in the denominator as well. So I add those fractions and then I divide and simplify, and I'm left with this final